So we got Al3 plus, that's aluminum's MCI. We got nitrite. We need 3 of those in order for them to balance out. So when we put them together, we're just gonna, I think the easiest way is to just write them next to each other first. So Al and NO2. And then since we needed 3 of the nitrite, we just put NO2 in parentheses and put a 3 on the outside. Okay. So just remember, for these polyatomics, you want to keep them together. Okay, you don't want to change the polyatomics at all. They're perfect the way they are. So all we need to do is put parentheses around them if we need more than 1. Okay. So if you have like a nitrite first, so hold up, just to verify, something like this. Yeah, that's totally fine. Today you'll see why this might be a little unhelpful, but this will be a correct answer as well. Okay. Okay, any other questions? All right, so we're gonna be doing more of this, but as you guys can probably tell by the name, maybe not nomenclature, but today's is called naming, and so we'll be learning how to name these compounds. Okay, so let's move on. So if you guys look on your chart, you guys should see at the bottom. You guys might have noticed it already. These are the naming rules. We're gonna be going over one of them today, and then we'll be going over the other one tomorrow. So we'll kind of break it up, just keep it a little easy. Okay. All right, so ionic compounds are made out of cations and anions. If you guys remember, cations are the positive one and anions are the negative one. Okay, so cations are the positive ones and anions are the negative ones. Okay, so what we're going to do is we're going to take a look at these rules. We'll refer back to this as we're doing the problem. So we're going to actually jump right into the problem. And you guys don't need to copy this down because obviously, you have it printed out on your handout. And we'll be using these. We'll refer back to this as we do the problem, okay? Okay, so I am going to give you guys, I'll give you guys 2 minutes to try out this one. So do the exact same that we did for the warm-up. I want you guys to write the balanced equation. This one's a pretty easy one. Lithium and chlorine's MCI. So write the equation. And then after that, we're going to go over how to write the name. If you think you want to try, you can try using the rules up here. But at least for the first 2 minutes, see if you can write the balanced equation for number 1. Okay. Take about 2 minutes to do that. Cool. Okay, so we're going to be reacting lithium's MCI and chlorine's MCI. Hey, no laughing. Okay, no happiness. Okay, so we got lithium right here. Lithium is in this column. So if you guys notice on the top of that column, there's a positive 1, right? So that means lithium's MCI is +1. Okay. All right. We're reacting that with chlorine, and chlorine is right over here. Chlorine has a -1 on the top. So obviously chlorine's going to be -1. Okay. Any questions on finding the MCIs? Hopefully it's not too bad. Okay. So we got Li plus. And we have Cl minus. And if we put them together, do we need to add any more of either of them? No, they're already balanced. So all we need to do is put them next to each other, LiCl. Okay, so what we're going to do now is we're going to name them. So the naming is actually pretty easy. So if you guys can pull out the naming rules, that will be helpful. Okay, so pull out the naming rules on your handout. All right, so if we take a look at the naming rules, now I'm going to scroll up a little. We always write the cation's name first, so the positive one first, and then the anion second. So let's start with the cation. So if you guys take a look at the rules, there are 2 rules for the cation. We're going to do this one next time, so you can ignore the second one. So if you guys take a look at it, it says for cations, they keep their name, doesn't matter what their charge is. So if it's Na+, we just write sodium. If it's Zn2+, we write zinc. So what do you guys think we should write for the cation name right here? Yeah, just lithium. So this part right here is lithium, and it keeps its name, so we just write lithium. Okay. There it is. Okay, so lithium. All right, now we just need to write the name for the anion, and this one we have to change it up a little bit, but it's not too bad. So I'm going to scroll up again. So if you take a look at the anion, it says anions that are 1 element. So chlorine is 1 element. we change the ending to IDE. So for example, chlorine becomes chloride, and then sulfur becomes sulfide. Okay, that's it. So we have Cl. So all we need to do is take Cl and we change the ending to IDE. So it's chloride. And that's it. This compound right here, the name is lithium chloride. Hopefully not too bad. All right. Do you guys think you could try some on your own now? Yeah. Okay. So I'm gonna give you guys about 5 minutes to try number 2 and number 3. There might be so just make sure you guys refer back to this table right here. Again, we're not gonna be doing this one today, so you can ignore this. We haven't talked about this one, but this is pretty self-explanatory. Polyatomic anions, they keep their names. So if we have this, just keep it nitrate. You don't need to change the ending. Okay, so with that being said, I'll give you guys about 5 minutes to try out numbers 2 and 3, and then after that we'll move on to the last couple problems for today. Okay, so take about 5 minutes to do that. All right, so we did aluminum's MCI for the warm-up. So what's the charge on aluminum's MCI?
3.
Yeah, 3. Okay, so aluminum's MCI is +3. If you guys take a look at cyanide on your polyatomic chart, cyanide is Cn-. So we're going to combine that with Cn-. And if you notice, it's pretty much the same thing we did for the warm-up. You're going to need 3 of the cyanides, and then it's going to react with 1 aluminum. So you'll get Al, and then parentheses, Cn3. Okay. All right, let's do the names now. So if you take a look at the naming rules, it says that for the cations, they keep their name. So we can just write aluminum. So we'll write aluminum. You know, in Australia, they say aluminium. Very interesting. All right, aluminium. And then we got the anion, which is cyanide. Now, we have this rule, but that's only for anions that are 1 element. Okay? Cyanide is a polyatomic because it's on the polyatomic chart, and it just keeps its name. Okay, so all we got to write is aluminium and then cyanide. That's it. So this one's a lot easier than the previous one. You don't need to change anything. Okay. Okay, I'm going to go through the next one a little bit more quickly. So we got ammonium. So ammonium is NH4+. Oxygen is 2-. So that means we're going to need 2 ammoniums to balance out the oxygen. So we'll do parentheses around the ammonium, 2, and then O. Any questions on that one? Okay, so the parentheses go around aluminum, I mean ammonium, because that's the one that you need more of. All right, let's do the naming now. So this one right here, we have ammonium as the cation, so we don't need to change the name of the cation. So we're going to write ammonium. Okay, and if you take a look at oxygen, oxygen is an atom with, or it's just 1 atom. So we have to change the ending to IDE. Okay, so I didn't tell you guys, oxygen is the one that's a little bit weird to name, but it's just going to be oxide. I know some people write oxide, and that's a good guess, but it's just going to be oxide. Okay, so ammonium oxide. Yeah, that's it. So on the test, if you forgot or you messed up and you put oxide, I wouldn't take points off for that. As long as you remember to change the ending to IDE and the front is somewhat the same, I'm cool with that. Okay. Alrighty, you guys ready for the last thing? And we'll be all done. Okay, so what we're going to be doing for the last thing is kind of reverse engineering this. So instead of giving you guys the formula, I'm going to give you guys the name and see if you guys can figure out what the formula is. So I'll do number 4 with you, and then you guys can try 5 on your own, okay? So we got the compound lithium phosphate, okay? So pretty easy for the cation. The name doesn't change. It's just lithium, so it's Li. Okay, now we don't know how many we need, but we'll write Li for now. Okay, the anion is phosphate, which is nice because it's just a polyatomic, so it's PO4. Now, if you look at the charges, Li wants to form what kind of charge? Yeah, plus, just +1. Good. And then if you look at your polyatomic chart, phosphate is 3-. Okay, so if we want to balance it out, which one do we need more of? Yeah, Li, obviously, right? So we're going to need 3 of those in total. So that means this is going to be Li3 to balance out 1 of the phosphates. Okay, so it's just going backwards. It's the exact same thing that we've been doing. All you're doing is just figuring out based on the name. Okay, and this is all I really need. So if you guys can figure it out like in your head, which is totally cool, you guys don't need to do this front part as long as you can give me the formula. Okay, only give me the whole balance equation if I ask for it. Alrighty, so I'll give you guys about 2 minutes to do number 5. I will let you guys know ahead of time. This one might be a little bit tricky. There are some compounds that have very similar names. Just make sure you're careful with the names, okay? So that'll be my little hint. I'll give you guys about 2 minutes. We'll go over it and then we'll be all done. So like I said, this one has a little bit of a trick in it. And if you guys notice, it's probably with the anion because the cation's pretty straightforward. It's just Sr, and strontium is going to be 2+. Okay. Now, if you guys take a look at nitride right here, okay, this looks very similar to some of the polyatomics, right? If you look, we have nitrate. We also have nitrite. Okay, but if you look at the polyatomics, there's no nitride. Now, if you look, nitride, IDE, has to do with anions that have only 1 element. And if you guys notice from the periodic table, we have nitrogen. Okay, so nitride is actually just nitrogen. Okay, so that was the little trick that was in there. Very similar sounding to nitrite, but this is not nitrite. It's just going to be nitrogen. Okay, so if you saw that, then good job. All right, so it is not balanced out right now, so you'll need 3 strontiums, 2 nitrogens, and if you put them together, you are going to get Sr3 and 2. And if you guys got that, you should be in pretty good shape at least for today. Okay. But that one was kind of a tricky one. Okay, so I'll give you guys the rest of the class period to work on your assignment. If you have any questions, please let me know. If you want to check your answers, please let me know. But yeah, we'll do the rest of the class to finish that up.
Yeah, I agree.